So I'm going to Vegas. I randomly got a bunch of foxes. So if you notice I split on Y in space, but you can do any letters you want. And we could make this longer, but there needs to come a point in our algorithm where we kind of stop and we say, okay, this is where it ends. Now, this is not how they created SHA-256 or some of the cryptographically secure algorithms, but we'll take a look at where this hash has some good features and some not so good features. So first off, if I run this again, it's not random. So if I run it again, I'll get the same result each time. So that means that if I ever, like for example, if I took this out and save it and run again, I got a different hash. So if you change it, you get different hashes. That's good. And if I ever type hello, comma space, and run it again, I should get that result back. There we go, all foxes. So we can use it for verification to some extent. Now where it falls apart, I'll just do hello and run that. Sweet, I got really close. Yep, so I can actually kind of do the math to try to figure out how to reverse this. But I'm going to go ahead and if I put in a comma, that'll probably be the same thing. So it'll change, the first one will change, but everything else will remain the same. So all I have to do is have it be enough letters that it's divisible by 8. So 1, 2, 3, 4, 5, 6, 7, 8. If I do that, fingers crossed, hopefully I'll get the fox again. There we go. So you notice that we had what's known as a collision. So collisions in these hash algorithms mean that two things can have the same hash. And that's pretty obvious because if we have a bunch of words and we only have 7 possible characters and 4 total spots, then of course there's probably going to be some collisions. So it's interesting, they spent a lot of time on some of these cryptographically secure hash functions to make sure that there's enough possibilities that even the largest file can go down to this group of characters, but the possibility of it colliding with anything else is very, very, very low. So our function, unfortunately, is not cryptographically secure because, like I said, if the password was hello, and they were able to type hello and a bunch of commas, or something really simple, then it wouldn't really work too well. But it does act like a hash. It fulfills the needs. Basically, it has a set number of characters, and no matter what we pass to it, it will have that output. And if we pass the same thing twice, we get the same result back. And that's kind of the basic beginning of like what a hash is. And we'll use it a ton in cryptography and cryptocurrencies.